Hey, Algebra 1, today we introduced the idea of inequalities, graphing linear inequalities in two variable, not just on a number line, but with x and y. So let's jump into some word problems and see what's up. So it says Jeremy's working two jobs, he's saving money for college, and he has an $8 per hour job working as working at a pizza place, it looks like, bussing tables, and then he makes $10 per hour tutoring peers at math. And that's how I started doing what I do now. So his goal is to make 160 a week. They ask, well, what if you were doing 8 hours and 11 hours at these two jobs? What's up with it? Are you going to have enough money to reach your goal? So the first thing I talked about was I said, okay, well, $8 times 8 hours plus $10 an hour times 11 hours, that gives you $174 total. So yes, in part A, Jeremy, if he works 8 hours and 11 hours, he should be good. So now it says write an expression to represent this idea. And so just like you see me in the top right corner in A, talking about 8 times how many hours I worked and 10 times how many hours I worked, same thing here. It's like I get $8 per hour at one job, $10 per hour at another job, and that gives me a total of 160, hopefully. Or in part C, it's saying, well, let's write an inequality that would show more than $160. So all I do is go more than or greater than or equal to. So we want to make sure I get this right. Jeremy decides he needs to make more than 160 each week. So I made a small mistake here saying or equal. If you're saying more than, it cannot be the same. So let me take that off, and that would change the graph a little bit. So if that's changing the graph a little bit, that if you were in class today, we are talking about when you use a solid line versus a dashed line. And so for this one, because it can't be or equal, we want to use a dashed line instead of a solid line. So let's change that here and say this should have been a dashed line. Let's talk about how we're getting this line. Let's start by subtracting 8x to the other side. Move this down here. Subtract 8x to the other side, and then after that, we just need to divide the 10 over to the right side. And this changes all of our values into more of an mx plus b format. So 16, that's my y-intercept. And I'm going down 4 and right 5 for my slope. And so I just figured out, well, if I went down 4 and right 5 multiple times, I would eventually hit the point 20, 0. Okay? So now, this is 0, 16, by the way. So now it says, according to the graph, if he's working 5 hours as a tutor and 10 hours, would he make more than $160? So, actually I missed a part. Part E says, is the point 0, 0 in the shaded region? So, I need to be shading greater than my graph because we want more than $160. So, when you go to graph this, make sure you are shading up and away from the line to basically show any point above this line would be fine. So now it says, what if he worked 5 and 10? So what I did was I went ahead and put in the graphing calculator this equation, and I did change the window a little bit so that I was only looking at 0 to 20 for the x-axis and 0 to 25 for the y-axis, and this gives me just the first quadrant. So I am going to put in 5. It said I used 5 hours for the for the busing. So when I plug in 5, I get 12. So that means that the point 510 had to have been below that line, and that would have been not in the shaded region. Okay, so this point right here would have been 510, and I know that because 512 would have been on the line. So it says, will he make more than $160? I would say no. It sounds like he's going to make less than that. And if you plug it in, 5 times 8 would be 40. And 10 times 10 would be 100. So that's only $140. That is not going to be enough for him to make his goal of 160. So now it says, due to days off from school, he's only going to be tutoring for 6 hours. How can we use this graph to understand the least amount of work that he needs to work? So similar idea. If you have it graphed, you can just go to your x-axis, go to 6, and go up and kind of figure out where you are. But I'm going to plug in 6 this time, and basically 11.2 is the exact amount of hours working the tutoring job. That would get me exactly 160. So that tells me that you better work more than 1.2 if you're going to land up in the shaded region. So I would say y better be greater than 11.2. And y, again, represents how many hours he works at the tutoring job. Okay, so talking about some graphing without stories here, I went ahead and set up A and B. So you're going to do, I don't want to mark through it because that makes it sound like you're not doing it. I want you to do C and D on your own, and we'll talk about that in class. So let's talk about A. The first step is so often the same. We need to move x to the other side. Much of the time, x is going to be a positive coefficient because standard form is not standard form if it's not positive. So we're going to subtract x to the other side. And now I'm going to divide everything by 3. So y is greater than negative 1/3 x plus 3. There's like a 1 right here, so I just made that negative 1/3 as a coefficient. So let's start at 3. And looking at my slope, it's negative, so I should be going down to the right. So I'm going to go down 1, right 3, down 1, right 3, down 1, right 3. I can even backtrack a few times. Okay, and now I'm going to ask myself, should this be dashed or solid? And so I notice that there is no or equal line under my inequality, so that means nothing on the line is in the solution. And that is why we use an open line, kind of like an open point on a number line for just less than or just greater than. Nothing on the point is in the solution space. And then I look at this symbol here, and that is the word greater than. And so I'm going to say, well, which is the greater side? Would that be above the line or below the line? And hopefully you're thinking, well, greater sounds like you're moving up. And you would be correct when you say that. So my solution space is any point that is above this line. And again, points on the line do not count because it is strictly greater than. Let's look at B. Same first step, subtracting 2 to the other side. And so often students miss the fact that there was a minus in front of that 6y or whatever that number is. And that really throws us off of the next part. So I want to divide everything by negative 6, and that is going to make my sign change directions. It's a very special rule with inequalities. Dividing by negative, flip the sign. So this gives me 1/3 x, and then this is going to be a minus 5/2. Okay? I think I did that correctly. I'm dividing both of these by 3, and that would in fact be 5/2, negative 5/2. Well, negative 5/2, that's the same as 2.5. If you were to do 5 divided by 2, that'd be 2.5. So I'm going to go down here to right in between negative 2 and negative 3, and I'm going to start estimating going up 1/3, up 1/3, up 1/3. Same thing moving down. And then for this one, because there is this or equal line, I will connect these with a solid line, and that means that all of the points on the line are a part of the solution because it is allowed to be or equal on both sides of the inequality. So now I'll look at where should I shade? Well, again, this is greater than. So should I shade in region 1 or should I shade in region 2? Well, you need to be shading above the y-intercept, all of the greater values on the y-axis. So I'm going to shade every point above the line. Sorry. Sorry about that. So any point here is in the solution space. Okay, so you try the other ones. I want you to try C and D. We'll check your work in class. Let's move on to some other problems. let's stretch a little bit. So if I was thinking about graphing this, let's go to the graphing calculator, and I'm going to put in this inequality, if it'll let me. Here we go. So I'm going to go to y equals, no I'm not. Let's try to get the calculator to work here. All right, there we go. So let's go to y equals, we'll clear it out. This is 2. Math for the absolute value symbol, we want x, double checking the problem, minus 3, and then I want to get out of that for the minus 5 part. So let's take a look at this graph, and if that doesn't look like you want to, zoom 6 helps you put it in a more standard window. So this looks like it starts around x equals 3, 3, negative 5. And later we'll talk about how these numbers can help you figure out that that's supposed to start at 3, 5. And if you use the calculator to find other points, if I was to plug in 4, you see it goes to negative 3. And it went up 2 over 1, and it's more linear from there on out. And so there is the beginning of my v going right. And then if I was to plug in a 2 value, you'll see that it is symmetrical, moving in the opposite direction with the similar slope. There we go. So now, if we're talking about greater than would be all the values above that vertex. And all of the points below it would be less than. So really, we want to graph every point that is inside this absolute value symbol. So I'm going to test that to make sure that's true. There's the point 2, 1, and that is clearly in the shaded region. So I'm going to plug that point in to see what I get. It's supposed to be that the y value comes out to be greater, so let's double check it. 2 minus 3 is negative 1. The absolute value of negative 1 would make positive 1. You then multiply that by 2 to get 2, and ultimately you subtract 5 to get negative 3. Is 1 greater than negative 3? Yes. And so I know that that point is in the solution along with every other point inside that graph. We've been talking a lot about solving compound inequalities, so you try A and B, and then, of course, if you don't mind, sketch me a picture of the number line to see what that answer looks like. Let's go to solving a system. I'm going to do A, you can do B. So when we're solving with combinations, that really is the idea of elimination, which is a phrase that, or a word that students are probably more likely to remember. So I'm going to start by considering, can I get 8 to become negative 16, or could I get 6 to become 7? Well, hopefully you're thinking, well, I could multiply 8 by 2, and I would agree. Let's double the top equation. That would be 16x minus 12y equals negative 40. And so the reason why they call it combination is because you're about to combine the two equations by adding. And if you do that, this one would cancel. 7 plus negative 12 is negative 5, and 30 plus negative 4 is negative 10. Let's complete the problem to find y at least, and y seems to be 2. And I'll let you finish this part out. We need to go back in and plug 2 in to figure out what x is. So anytime you answer a system, it's important to know where they cross, and these are always ordered pairs with x and y's values. So finish up 2a, see what you get for x, try b, and we'll see what you do in class. So for time's sake, I started this one over so that I could basically show you a little quicker. The slope is 2/3, but I do not know the y-intercept. So I have replaced from the point 2, negative 4. I've plugged in 2 for x, I plugged in negative 4 for y. And to figure out my y-intercept, I'm going to subtract 4/3 from both sides. So let's see what that would be. Negative 4 minus 4/3. Looks like that back number should be negative 5.3 repeated, or negative 16/3. So let's round this problem out. this final answer should be y equals 2/3 x minus 16/3. Hope this video was helpful, and I will see you tomorrow in class.